Today we are going to learn about exponential growth and decay and the word problems that are involved specifically. So let's just start. This is easier when we're actually in a classroom, but we'll try. We're going to say that on day 0, that only one person knows a secret or a rumor about something. So only one person knows before coming to school the first day. Only one person knows. And we're going to try to look for a pattern that will help us determine what our exponential function is. Okay, on the first day, let's just say every single time you're going to tell 2 people. So this one person tells 2 more people, and so there's going to be 3 people at the end of day 1 that knows the rumor. Then we'll come the next day, and each of those 3 people are going to tell 2 more people. So one person tells 2 more, that makes 3. Another person tells 2 more, that makes 6. And another person tells 2 more, which makes 9. And then on day 3, if we had enough people, each of those 9 people will tell 2 more people, which is going to make 27. And this would go on forever. So try to figure out a pattern. First, day 1, we just have one person that knows. And then somehow we get it to be 3. The only way I can think of to get 3, if you're looking at the rest of the pattern, is multiplying by 3. So 1 times 3, which will be 1 times 3 to the first, and I'm keeping it that way for a specific reason. And then to get 9, you'd multiply the previous one by 3 again. So you'd have the 1 times 3, but you'd multiply it by 3, which 3 times 3 is 3 squared. Oops, sorry. 3 squared. Then to get 27 from 9, you have to multiply by 3 again. So you already have the 1 times 3 times 3, but times 3 again, and that's going to get you 1 times 3 cubed, because there's 3 3's. And again, this pattern will continue forever. So if you notice, it's the number of people we start with and we have then a base to an exponent. So our exponential function is going to look like this. Y equals AB to the x. And this is something you have to memorize. We're going to be using it the next couple days also. We're kind of taking a break from all the simplifying exponents, so some of you will be happy. And we're going to be using y equals AB to the x. This you need to memorize. And know that A is kind of like our 1. It's our starting value, or how many people in this specific example we started with. So A is the starting value. Or starting amount, let's say that. And that's when x equals 0. So we want it on day 0. That's where we're always going to start. So don't start on day 1, we're going to start on day 0 with the starting amount before any days occur. And this could be transferred into years, months, whatever, but normally in Algebra 1, the only examples you'll see is days. So let's look at our first example. We'll be using this. We will start out with our y equals AB to the power of x. We know that already, and we're just going to be reading number 1 and filling in values for A, B, and x. So if the population of rabbits in the neighborhood triples every year, and there are currently 345 rabbits, how many rabbits will there be in 9 years? Okay, a couple things that are happening is that we know our A is our starting value. So we're like, how many rabbits do we start with? 345. That is going to be your A value. So we put 345. And the B part is going to be like how much it's going to be growing. And this time it says triples. And then whenever it says doubles, triples, quadruples, you're just going to put a number. As you'll see on the rest of the examples, there's another way to find the amount of growth or decay. But when it just uses the words like this, the triples, we're just going to use a 3. And then the x will represent number of years. So if you want to add that up here. So x will represent number of years or number of days. I guess normally we'll see number of years in Algebra 1. Sorry. If I said days, it could be days or years. We'll see both. So the number of years that we want to find it in is 9. And I'm going to write it just generically at first because on your homework you're going to be you'll be filling in your A and your B value, and you're going to have different x values. So for this specific example, yes, our 3 is to the 9th year, but when it's asking for an equation on your homework, that's what you're going to give. The generic or the general equation is what it's called. You'll do it with just an x, no number. And this is what we have to talk about also, because if you want to do it in a couple steps, some of your calculators will make you don't multiply first, which is what you'll want to do. You have to actually do exponents first, 3 to the 9th, and then multiply by 345. But as you'll notice, a lot of your calculators will do this correctly for you. So let me show you how to type it in correctly. If we have this, you type in 345, then you'll have the parentheses 3, and then to the power of 9. Your calculator will actually know order of operations, so if you can type it in all at one time, then you're going to be good. And this will give us, let's look, fill in our commas, and this gives us 6,790,635 rabbits. And we do want to always label. Please always label. So this, we're talking about rabbits. Sometimes it's going to be money. Just please always label your answer every single time. Get used to it. Okay, let's move on to the second one. If the population of Fort Wayne is 256,496 and is growing at a rate of 13% per year, what will the population be in 12 years? So we have a few pieces of information. We're still going to start with our y equals ab to the power of x.